This video is for my pre-algebra classes. It's over lesson 35, similar and congruent polygons. So ladies and gentlemen, similar polygons have the same shape. I'd like you to please grab your yellow highlighter and highlight that. They have the same shape. And so if you think about a polygon, what creates the shape of that polygon is the angles. So depending on how widely open the angles are or how narrowly open they are, that's what's going to create the shape. So you get a particular triangle if you have one angle, you get a different triangle if you have a different angle. So the shape is controlled by the angles. Now you'll notice that this doesn't say anything about the size of the shape, and that's on purpose. In mathematics, if we don't mention something, it means it's not important. So whether these two figures that we're comparing are the same size or they're different sizes, it doesn't matter. All that matters when we're talking about similar polygons is that they have the same shape. Now, congruent polygons, on the other hand, also need to have the same shape. So grab that yellow again. However, they also need to have the same size. Grab your orange, please, and highlight size. So similar figures just have to have the same shape, but congruent polygons have to have both the same shape and the same size. So one of the things, hopefully, that you'll notice here is that as a consequence of this, it means that anytime you have congruent polygons, they are also similar. Now that's not really worth mentioning because similar gives us less information than congruent does. So we'd want to go with the label of congruent there. But it's still true that anytime you have congruent polygons, they are also similar polygons. So if we take a look at the figures over here to the side, if I tell you that triangle ABC and triangle DEF are similar but are not congruent, then that tells me right there that they have the same shape, but they do not have both the same shape and the same size. Well, if we already know that they have the same shape, then it must be the size that's different that makes them not congruent. So grab a color other than yellow and orange. I'm going to choose my green here today. So I'm going to highlight the word similar. And then down here symbolically, we see the similar symbol. So the similar symbol looks a lot like the approximately equal to. It's like half of an approximately equal to sign. It also looks like, if you take Spanish, it looks like the tilde that we put over the N for señor or señorita or señora. Now, in this example here, triangle ABC and triangle RST are congruent. So if you grab a different color highlighter, I'm going to choose my blue this time. So congruent, and here's the congruence statement symbolically. So the congruence statement symbolically might be a little hard to see here in my video, but you should be able to see this on your copy of the handout. I'll do it on my dry erase board here. But the congruence symbol reuses that tilde, that half of an approximately equal to sign, but it puts it over an equal sign. And that's our congruent symbol. That's our congruent symbol. So triangle R or ABC is congruent to triangle RST. Now, congruence and similarity statements are important because they're always named in corresponding order. So name corresponding parts of similar or congruent polygons in the same order. So by writing triangle ABC is similar to triangle DEF, then I know that A corresponds to D, B corresponds to E, and C corresponds to F. Likewise, triangle ABC is congruent to triangle RST, means that A corresponds to R, B corresponds to S, and C corresponds to T. So this is an important idea here. I want you to take your red pen. We're going to draw a little bit of attention to it. So go ahead and do that, and let's draw some attention. So the chart below names the corresponding parts and angles of triangle ABC and triangle RST. So if they're written in those orders, then we know what corresponds. So the angles and the sides. So A corresponds to R, B to S, C to T. So real easy angles. Angle A corresponds to angle R. Angle B corresponds to angle S. Angle C corresponds to angle T. Now when it comes to the sides, it's a little bit more involved, but it's still the same idea. So segment AB, well, A corresponds to R and B corresponds to S. So segment AB corresponds to segment RS. Segment AC corresponds then to segment RT, and segment BC corresponds to segment ST, because B corresponds to S and C corresponds to T. So if you can make these connections, then we have certain relationships here. So first of all, grab your yellow. Remember up here that we talked about similar polygons have the same shape, and it's the angles that make the shape of the figure. So corresponding angles of similar figures have to have the same measure. And that's what will give them the same shape. Now, since congruent polygons are also the same shape, their corresponding angles also must have the same measures. So whether we're dealing with similar figures or congruent figures, the angle measures of corresponding angles will have the same measure. So if the angles control the shape of the figure, it's the sides that control the size of the figure. So in orange here, corresponding sides will control the size. So if they're congruent polygons, they have the same size, they must have the same length of corresponding sides. However, similar polygons do not have to have the same size. But there's still a relationship. The relationship here, though, instead, is that they're proportional. Corresponding sides in similar figures will be proportional. And if we think about what we've learned about proportions, one thing that's very helpful is our ratio box. So if you imagine a ratio box, we can compare sides from one figure to a second figure. And so we can have one pair of corresponding sides and a second pair of corresponding sides and create a proportion out of that. So let's draw an arrow over here. So it says here, use a proportion to find the missing side of a similar polygon. So if we know that these two guys are similar, then I'm going to make my proportion. So if we imagine this box here, so on the figure, one of the figures, doesn't matter which figure, so maybe we start with the first figure, I'm going to put one side length over another side length. So maybe x over 8. So they're both from the same figure. And then equals, and then in my second figure, one side length that corresponds to the first one, and then a second side length that corresponds to the first figure. So in this new rectangle, what corresponds to the x? 6 does. So 6 will go up top. And then on the bottom, what corresponds to 8? the 4 does. And so there is my proportion. So if we solve this, remember the arrows that we used to solve this. The x is in the upper left. So can we move left or up? Well, if I go up, we got to multiply 4 times something to get a 6. We could figure that out, but it's not going to be super obvious. Or instead, I could multiply 4 by something to get an 8. That sounds a lot easier. So let's go to the left here, and we're going to times by 2. Because 4 times 2 is 8. So 6 times 2 should be x. Therefore, x is 12. So it says, recall that to solve a proportion, you need to find a constant factor. Well, it doesn't always have to be a constant factor, because remember, we can go up and down. The constant factor is the number we would use going left and right. Well, this time we did go left, which means that that 2 we used is our constant factor. I'll choose a new color here. And just a quick note about the constant factor. Remember, this is the number used to go left or right across the proportion. So because 4 times 2 is 8, therefore, in this case, our scale factor would be 2. All right, so let's apply this now to the examples at the bottom of the page. So complete the statement. Triangle BXR is congruent to, well, if we look at these figures, so BXR, triangle BXR. So we're looking for something that has the same shape and same size. So particularly, I'm looking to see here at the markings. We can't just assume in geometry. We have to actually look at the markings. So we'll notice that each one of these triangles is a 30, 60, 90 triangle, 30, 60, 90, 30, 60, 90. And so that's going to help us to identify things in just a moment. But that means that all the corresponding angles, there will be corresponding angles that will be congruent. So we know all 3 of these triangles are similar. Now the only thing is which ones have the same size. Well, ladies and gentlemen, remember that we use tick marks on the sides to show that they're congruent. So this single tick mark side here must be congruent to that single tick mark side there. This double tick mark side here must be congruent to this double, and this triple must be congruent to this triple. So therefore, these 2 triangles must be the same size. So same shape, same size. It's this guy that's congruent to triangle BXR. Now to put them in corresponding order. So triangle BXR, first we have B. If we look at angle B is a 60-degree angle. So it needs to correspond to the other 60-degree angle, angle G. So this will be triangle G. I'm going to make that a little sharper so it doesn't look like a 6G. And then X is in the middle. Well, X is the 30-degree angle, which must correspond to the other 30-degree angle, H. So triangle GH, and then, well, process of elimination must be the last guy out, plus R is the right angle, which must go with the right angle, J. So whether you use process of elimination or notice they're both right angles, triangle BXR is congruent to triangle GHJ. And that is the only acceptable answer there. If you were to mix those 3 letters up in any other order, that would be wrong. So for number 2, triangle BXR, well, first of all, we know that all 3 of these triangles are similar. They all have the same shape. They all have corresponding angles that are equal. So I know triangle BXR is similar to triangle GHJ. but it is also similar to this little one over here. So I'm going to add another similar statement. And so it's the 60 degree, then the 30 degree, then the right angle. So 60 degree here would be L, 30 degree would be M, and the right angle then would be N. So triangle BXR is similar to triangle GHJ, which is similar to triangle LMN. All right, for number 3, BX over XR equals GH over something. So quick thing of note here, when we say BX just all by itself, BX is actually the length of segment BX. So remember that when we leave that segment symbol off, we're talking about the length of the segment, which is a number. That's why we can use it in a proportion. Well, using these similarity statements and these congruent statements up here, we should be able to fill this in real easy. We know that B corresponds to G. That's why this is B, that's G. We know that X corresponds to H, which is why this is X, and that's H. So down on the bottom, we already know that X corresponds to H. So I know this is going to be H. And then R corresponds to J. So I don't even have to look at the figure. I can use the similarity statement there. Now, if we did look at the figures, however, I would want to look and see, okay, BX, I might look at BX and say, all right, BX is the hypotenuse. So GH is the other hypotenuse. I might look at XR and say, all right, XR is the leg that has a single tick mark. So over here, HJ is the one that has the single tick mark. Or if these were not congruent, let's say they were different sizes, I could say that that XR is the leg that goes from the 30-degree angle to the right angle, would be another way to identify that. So HJ also goes from the 30-degree angle to the right angle. So there's a few different ways to think about it. Number 4, the measure of segment HG. Now, ladies and gentlemen, while this is technically correct, don't write that. As we just talked about, we would just write HG because it means the measure or the length of segment HG. So if we look at HG, segment HG, that's the hypotenuse here. Well, there's no measurements actually on this triangle at all. However, we do have things marked as congruent. So with 3 tick marks here, if we look over here where the 3 tick marks are, we see this is marked as 20 millimeters. So we can put that together. We know that HG must be equal to, because it has 3 tick marks here and that has 3 tick marks there, it must be equal to XB. And we know that XB is equal to 20 millimeters. And so we're going to make this logical connection to show our thinking, that we know that HG has the 3 tick marks, which matches the 3 tick marks on XB. And then we know that XB is 20 millimeters. For number 5, we want the scale factor from triangle LMN to triangle BXR. All right, so, well, let's make a proportion out of this. So let's say we have this X here. Let's take a look. So we want the scale factor, so I'm going to make a proportion. So my first figure here, let's use some sides from triangle LMN. So LMN, I see I've got an X and I've got a 5 millimeters. So I'm going to just make this X over 5. So now triangle BXR, I need to compare these. So X is the hypotenuse it must match up with this hypotenuse, which is 20 millimeters. The 5 millimeters is the leg that goes from the 60 degrees to the right angle. So 60 degrees to the right angle here is 10 millimeters. So x corresponds to 20, 5 corresponds to 10. So if we consider how would we solve this, well, specifically I'm looking for the scale factor. So in this case, we've got to go left or right to find the scale factor. So if I look here, since x is on the left, let's go to the left. So 10, how do I turn that into a 5? I divide by 2. So therefore, this 2 is my scale factor. The scale factor from triangle LMN to triangle BXR is 2, because that's the number we'd use to go left to right in our proportion. Last up, the measure of LM. Again, we wouldn't write it like that, though that's not technically wrong. We would just write it as LM. So LM in this case, well, that's x. Well, we've already started our work here if we just finish it. So if 10 divided by 2 is 5, then 20 divided by 2 must be x. Therefore, x must be 10. So LM equals x, which equals 10 millimeters. And of course, we'd have this work for that. And that, ladies and gentlemen, is our lesson.